Hi, welcome back to Math 111. Most of section 2.1 is pretty self-explanatory, but I do want to talk to you about the intercepts of a graph of an equation. By now you will have looked through section 2.2 and you will know that the graph of an equation is a picture of the points that satisfy that equation. So, for example, if I were to graph the equation x squared plus y to the third equals 1, I could start by making a table of values. And so make an x and a y. And if x is 0, y is 1. And if y is negative 1, then x is 1. So I've got a couple of points already. I know the point 0, 1, and I'm going to do this. So this is 1, this is 2, 1, negative 2, negative 3, okay, so I've got the point 0, 1. Oops, my bad. If y is negative 1, x is 2. Oh. Yes, that is correct. Okay. If x is negative 1, y is 0, and if x is 1, y is 0. And if x is negative 2, y is also negative 1. All right, so I've got a couple of points. I've got the point negative 1, 0, the point 1, 0, the point, those are not right. This is incorrect and this is incorrect. There we go. All right, so there's no more pretty points. We could figure this out. So let's take a look at this point that I crossed out here. If x is 2, what that means is that 2 squared plus y to the third is equal to 1, which means that y is equal to the cube root of negative 3, which is not a nice nifty number. It's a decimal. We could figure out that decimal. Desmos can do that. And we get negative 1.44. So this is approximately negative 1.44. And that same value applies if x is, let's see, that was for positive 2. The same thing happens if x is negative 2. So we're going to put this guy here, this guy here, and we could figure out a couple more values, but our function ends up. So this is not, the dots are only waypoints on our function. Our function actually looks like this. And we could have Desmos do a nicer graph for us, but that's what our function actually looks like, is the line connecting, going through those dots. and continuing on out. Now, what I want to talk about is a couple of special points on here. So the special points that I'm going to talk about right now are called the intercepts. We've got different types of intercepts. We've got X-intercepts, and we've got Y-intercepts. Now, on our graph, the X-intercepts are the points where our function crosses the X-axis. So these 2 points right here that I've circled are my X-intercepts. So I've got X-intercepts at the points -1, 0, and 1, 0. My Y-intercept is the point where my graph crosses the y-axis, which in this case is the point 0, 1. So the key here is that X-intercepts have a y-coordinate of 0, as you can see. Y-intercepts have an x-coordinate of 0. So to find x-intercepts, you set y equal to 0 and solve for x. To find y-intercepts, you set x equal to 0 and solve for y. So, for example, let's find the x and y intercepts, if there are any, and there might not be, of the graph of the relation x minus 2 squared plus y squared equals 1. So let's start with the y-intercept. To find the y-intercept, we set x equal to 0 and solve for y. So this means 4 plus y squared equals 1. Y squared equals -3. Now, under the real number system, that means that y would be the square root of -3, which is not a real number. We'll talk more about that later. But what this means is that there are no y-intercepts. Okay, so let's find the x-intercept, if there is one or two or more. To find the x-intercepts, we set y equal to 0. And this means that x minus 2 squared equals 1, which means that x minus 2 equals 1, or x minus 2 equals -1. So we get x equals 3, or x equals 1, which means that my x-intercepts are at the point 3, 0, and 1, 0. Okay? Now if we were going to go on and graph this thing, we would plot some more values, and what we would see is that we've actually got a circle. This thing makes a circle of radius 1 centered at the point 2, 0. that is the graph of that relation. Okay. So that's it for intercepts. I'm going to come back in a minute. I'm going to talk with you about testing the graph of an equation for symmetry.